The percentiles function calculates values that are greater than X% of the sample set. Let me execute this sample, and I think it'll better illustrate what I'm talking about. For the counter name available M bytes, I want to summarize my counter value. So I pass in counter value as the first entry into percentiles, and I'm dividing this up by computer. I've indicated that I want to get percentile values for 5, 50, and 95%. On the first row of the return set, Contoso Web VM1, the first column, percentile counter value 5, reads 6,551. This indicates that this value is greater than 5% of the values in my incoming sample set. If I move to the next column, you'll see the value is 6,570. This means 6,570 is greater than the values of 50% of the data. Likewise, for the 95% column, the value is 6,581. These column names, well, they're not the prettiest in the world, so I can actually rename these if I want to using two different methods. The first, I can use the project rename. When I execute this, I'll have new values for each column. There is a slightly better way of doing this, though. In previous sections, you may recall seeing where we take a column name after, say, summarize, equals, and then the calculation. Well, in this case, I'm actually returning back 3 values from my percentiles calculation. So all I have to do is put my 3 new column names inside of parentheses. Summarize, parenthesis, %5, %50, %95, equals, and then there's my 3 result sets. And you can see I get those 3 columns back, and it's a little easier to read. Of course, I don't have to settle for just 5, 50, and 95. I can use whatever values I wish. In this case, I'm actually going to bring back 5 different percentiles: 10, 30, 50, 70, and 90. There's a variation of percentiles that will return the data as an array, percentiles underbar array. When I execute this, you're going to see that instead of 3 different columns, I'm getting the values for 5, 50, and 95 all placed into a single array. We can combine this with the MV expand we've previously seen and convert that back into individual rows. As you can see in the results set, I get bytes received per second, 0, 0, and 2101, representing 5, 50, and 95% of my values.